Hello everyone, welcome back to my channel. So in this video we are going to learn about invertible and non-invertible systems. Invertible and non-invertible systems. If you are first time to my channel, please consider subscribing and make me encouraged. So a system is said to be invertible. A system is said to be invertible if we can recover its input from output. If we can recover the input from output, then it is said to be invertible system. Okay, so a system is like this. Suppose some transformation you are going to make and you are going to have some output. So x of n or x of t you are taking and you are getting y of t. So this y of t is passed through some other system which is the inverse of the first system. Then you are going to have the input. So if you can recover the input from the output of the system, then such type of system is said to be inverse system. Okay, so this is the concept wise it is okay. So if you are given with problems, then how can you find whether the given system is invertible or not? So for that, two important points you have to remember. A system is said to be invertible if first point which you have to remember is for any input output should not be equal to 0. Output is not equal to 0. For any input, output should not be equal to 0. If for any input, if output is equal to 0, for any input, output is equal to 0, then it is said to be non-invertible system. Okay, opposite of this statement. For any input, output is equal to 0, then we can say that it is a non-invertible system. For any input, if output is not equal to 0, then we can say that it is a invertible system. That's all. Second, for two different inputs, for any two different inputs, output should not be same. Okay, so different output, that is, what does it mean? Different inputs should lead to different outputs. Different inputs should lead to different outputs. Okay, so for any of these condition, if they satisfy any one of these condition, if even one of the condition is not satisfied, then we can say that it is a non-invertible system. For an invertible system, both the conditions must be satisfied. Okay, so even if one of the condition is not satisfied, then it is a non-invertible system. Okay, so this is how we can find whether the given system is invertible or not. Okay, so next we'll see some of the examples and you'll understand clearly whether when a system is given for you, you can comment on invertibility or non-invertibility. So first problem, I'll take y of t is equal to d by dt of x of t. That is differentiation of input. So when x of t is a DC signal, okay, so when x of t is a DC signal, suppose 10 volts you will take, 10 volts I am taking, so y of t is equal to d by dt of 10. So differentiation of a constant is equal to 0. So for a given input, output is going to be 0, which violates rule number 1. So what is rule number 1? So for any input, output should not be equal to 0 for a system to be invertible. But since it is 0, therefore the given system is non-invertible. Non-invertible. Okay. So we'll take another question. Y of t is equal to x square of t. So y of t is equal to x square of t. So I am taking two inputs. X of t is equal to u of t is one of the input, and x of t is equal to minus u of t is another input. Suppose how will be u of t? U of t is like this. For all values it will be equal to 1, right, from 0 to this. So what will be minus u of t? Minus u of t is like this. This is the timeline and this is your amplitude, which is equal to minus 1. So both are not same. Okay, so this is your timeline and this is the amplitude. Now this is your timeline and this is the amplitude. So both are not same. That means different inputs are applied. And what will be y of t? Y of t is equal to u of t whole square. So it becoming u square of t. And when you are having minus u of t also, y of t is becoming u square of t only. So for two different inputs you are applying, you are getting the same output. So for two different inputs, output is going to be same, which violates rule number 2. So for any two different inputs, output should not be same. So since it is violating rule number 2, it is also a non-invertible system only. Okay. Right, we'll move to the next question. So y of t is equal to modulus of x of t. Modulus of x of t. Same, I'll take x of, when x of t is equal to u of t, then y of t is equal to modulus of u of t, which is equal to u of t. And similarly for the second case, b y x of t is equal to minus u of t. If you take, then in this case y of t is equal to modulus of minus u of t. So it will be u of t again. So for two different inputs, the output is going to be same. Therefore it is also non-invertible system. Non-invertible system. Suppose I'll take another example. Y of t is equal to x of t minus 4. X of t minus 4. Okay, same, u of t I will take and minus u of t I will take. So in this case, for x of t is equal to u of t, so what will be y of t? Y of t is equal to u of t minus 4. And when x of t is equal to minus u of t, then y of t is equal to minus u of t minus 4. Okay, so for different inputs you are getting different outputs. Yes or no? So how will be u of t minus 4? T minus 4 starts from 4 and its amplitude is going to be 1 from 4 to infinity. And how will be minus u of t minus 4? So it starts from 4 and ends at infinity, but its amplitude is going to be minus 1 only. So both are different. Different inputs leads to different outputs. Therefore it is a invertible system. Therefore it is invertible system. Therefore inverse system is given by x of t is equal to y of t plus 4. This 4 gone that side. So if you add 4 only to the given t, then you will get x of t is equal to y of t. That is, you can recover the input of the signal from the output. You can recover the input of the signal from the output. So this is said to be inverse system. Okay, so first of all you have to find whether the given system is invertible or not. If it is invertible, then you can find the inverse system like this. Very simple. Okay, if it is not invertible, then no need to find the inverse system. So last problem we'll take. Y of t is equal to integral minus infinity to t x of t dt. Y of t is equal to minus infinity to t x of t dt. So for u of t is for x of t is equal to u of t, what will be our output y of t? So integral of u of t is r of t. When x of t is equal to minus u of t, then what will be y of t? Y of t is equal to minus r of t. So no, minus r of t. So different inputs, So r of t minus r of t. So different inputs here leads to different outputs. So it is again invertible system, and the invert system is given by, so we need x of t, send this integration that side, it becomes differentiation, d by dt of y of t. So this is said to be inverse system. Okay, this is the inverse system. Okay, so this is the procedure to find whether the given system is invertible or not. If it is invertible, you can find the corresponding inverse system. That is, we need x of t in terms of y of t. So whatever x of t is there, you have to find. So in this case, x of t is obtained by adding 4 to the time axis. So x of t is equal to y of t plus 4. And in this case, sending this integration that side, you will get differentiation. So integration invert system is differentiation. We obviously know that. Okay, and this is the proof. Okay, so this is about invertible and non-invertible systems. Okay.